Why do your kids do this?
I know who did that. That's first period there.
It's way.
All right, get at your homework.
Why, Chris? Oh, Mr. Chartier.
Why did people just walk out when the bell just rang?
Did you find Iliad book?
No Iliad book, but I did find 2 lunch boxes.
It's mine.
Next to the printer.
Oh my God, that's mine.
I'm pretty sure they belong to people in this class. All right, hurry up. Let's get that under control. Take your seats. All right, here we go. Rowan, find your seat. So, any questions on the homework?
No.
Okay. So, factoring starts off pretty simple because we're factoring special case ones. Today is slightly more challenging. New rules, but still pretty simple. And then next week it becomes challenging. Okay, I'm no lying. It'll be one of the hardest things that we do next week. Okay. Some of you will catch on very quickly and say that she's still full of it because it's easy. Odds are, yeah, but that's the way it goes. And I don't want you to think that I make things up to try to, confuse you by saying, well, he says it's hard, but I find it easy. Trust me when I say there'll be kids in here that will struggle at this, and you will look at it and you're like, what in the world is that kid's problem? How do they not get this? Right? Because people's brains work at different levels. Eventually, we all get to where we get this, but it takes people different times, or time spans to get this. Some kids are quick learners, some kids are a little bit slow. All right, there are no questions? All right, check your work. Here we go. Check your work. Number 1, y squared. Listen, please, and stop. Y squared minus 49. Number 2, m squared minus 64. Number 3, 16 minus x squared. Number 4, 81 minus w squared. Number 5, 25y squared minus 4. Number 6, 64x squared minus 121. Number 7, 1 minus 9a squared. Number 8, 49 minus 4a squared. Number 9, 9x squared minus 4y squared. Number 10, 16w squared minus 36z squared. Number 11, 16s squared minus 25t squared. Number 12, 49p squared minus 25q squared. That's multiplication. And then we do the reverse, the factoring. The 27 through 36 for the factoring. 27. Now, I'm going to give you an order. Your order could be opposite. If I say plus and then minus, and you wrote minus then plus, it's the same answer. The 27 is b plus 6, b minus 6. So once again, if you wrote b minus 6, b plus 6, that's the same answer. 28, m plus 5, m minus 5. 29, 2c plus 9, 2c minus 9. 30, 3a plus 10, 3a minus 10. 31, 5z plus 1, 5z minus 1. 32, 4x plus 3, 4x minus 3. 33, 13u plus 15, 13u minus 15. 34, 9n plus 11, 9n minus 11. 35, 1 plus 3a, 1 minus 3a. And the last one, 12 plus y, 12 minus y. Yes?
Yep.
Okay. All right. Somewhere here. Riley's coming around to collect. Piper's passing out. You guys are going to write down your homework. You have 6 days to get it done.
Can I get my back?
I'm not going to get it done.
Not right now. Okay. Quiz, let's see. Quiz next week on Tuesday, or sorry, Wednesday. We will do a review on Tuesday. And your homework, if this thing ever clicks, there we go. This is going to be a repeat of yesterday, except with new rules. It's close, but not exactly.
Are we just going to multiply with consecutive?
It's going to be both multiply and factoring again, but it's got a new set of rules.
So these are special cases again?
Yeah, last day of special cases.
Last day is a special case.
They are the easiest ones.
Why can't we have 6 more days?
Yeah, exactly. Hey, Rowan, you're not the dentist.
Because only Rowan can still. Yeah.
Rowan, do you have dog lips? Is that the problem?
Yes.
No.
What do you mean, no? Can't see.
No.
Why? Why will explain?
Okay,
Why am I building a
so standard speech here. Hey, we're about to learn something new. Listen, please. Listen. Listen. We're about to learn something new. You've not done this before. It requires paying attention. It requires doing the examples. You got to trust me and trust the process that you will eventually get this. If you thought yesterday was an easy day, today should be an easy day as well. If you thought yesterday it took you a while to get this, I'm noticing that most people aren't paying attention. If you thought yesterday it took you a while to get it, today will take you a while to get it. Okay? But trust me when I say this, compared to what we will do next week, this is the easy stuff. All right. So we're going to be talking about something called squares of binomials. In bigger terms, we're going to do exactly what we did yesterday with a different type of special quadratics. Okay? So more special cases. We've already done this one. This is the one from yesterday. It's called the product being multiplication of something added. That means sum and a difference. So here was the product, multiplying two binomials, product of a sum, that means the plus, and a difference. We already know this. Rylan, the answer is?
Wait.
You got it.
Okay, 9x subtracted.
9x squared.
9x squared subtracted by.
Okay, so we've already done that one. When the instructions say simplify, those are fancy words for doing the math around. Did that. Remember, we went this way, multiplying, and then we went the opposite way for factoring. Okay? So the opposite way for factoring is when I give you a special case quadratic and ask you to factor it. You got to ask yourself 2 questions. Is 4 a perfect square?
Yes.
Is 81 a perfect square?
Yes.
There's no middle term. In that case, then it's going to turn into something that looks like this. So you take the square root of the first one and you get 2x. You take the square root of the second one and you write 2x plus 3, 2x plus 9, 2x minus 9.
Oh, never mind. That's a different problem.
Yes?
Yeah.
Right. Yeah, not the same
Yeah,
problem.
I thought it was.
So here was our first. I said there were 3 of these. Yesterday we did 1 of them. Here's our first one. This is what you're supposed to be experts at now. Okay? For those of you that aren't experts, what will save your butt come quiz and test day is you have an example of this. I'm going to claim that if you have an example of this, this is really easy to see the patterns. If you don't have an example of this, you're going to have to solve this the hard way, which is what I'm going to teach you next week. For the ones that are not special case, you got to do it the hard way. The hard way takes a lot of time. If you notice that it's a special case, you get to the answer like nothing, like quickly. Today we get 2 more of these. They're different. They don't look like this, but they are still special case. So special case quadratics, there's a total of 3 of them. Remember, quadratic just means that the x is to the second power, or whatever the variable are. There's 3 of them. We've learned 1, so we get the 2 today. These 2 are I would say these are more medium than easy. Okay, so a quick note of the difference between yesterday's special case and today. Hey, here's here is a normal quadratic, right? Notice on a normal quadratic, we always get a middle term. And by the way, most quadratics, except for this one, you get middle terms. So typically when you multiply a binomial times a binomial, you get a trinomial. Yesterday, we got a binomial. That only happens when it's plus and minus the same thing. If it ever says plus 9, minus 9, or whatever the numbers are, you lose the middle term. Why? This gives you a positive 27, this gives you a negative 27, and they turn into 0. But most quadratics, that doesn't happen. This gives you 15x, this gives you negative 4x, 15 minus 4 is 11. You get a middle term. Okay? So today's, they will all have middle terms. So it's like we got double the work. Previously, you square this, and you put a minus sign in between, you're done. Today, we're going to get a middle term. So we got to handle that. Okay, same drill as yesterday. If you remember how I did this, I showed you two things I wanted to multiply together. Each row did one, and we noticed a pattern, and we wrote a rule. We're going to do the same thing today. Okay, so this is the one that we're going to be doing today. Notice it doesn't say plus, minus. It says plus, plus. So this is flavor 1, right, or flavor 2, I guess, right? By the way, this is that. Check it out. If it's x plus 3 times x plus 3, then it's quantity x plus 3 squared. This is how they will write it. This isn't the answer, by the way. This is how they will present the problem. They will present the problem looking like this. But just remember, this would be the base, written twice, can be written like that. Hopefully you're not lost so far. Okay? This is called the square of a sum. This is flavor, we'll call it 2. And the second one, take a guess what it will be. It'll look exactly the same, except it will have a minus sign. Okay? So this one won't be called a square of a sum, it's going to be called a square of a, what's the magic word for subtraction? Difference. So this one will be called the square of a difference. So these are the two flavors that we're going to do. I'm going to give you this. You're going to actually do the multiplication, except I'm not going to give you this. I'm going to give you this. You're going to have to know that this turns into this, and then you do the drill of whatever the answer is. Okay? And we're also going to factor today as well, too. Okay. That's what we did the other day as comparison. This one is called the product of a sum and a difference.
So what if it was x plus 3, x plus 5?
That's next week, and that's the 5-minute process. Okay? All right, so reminder once again, they're going to give you this as the starting point. You turn it into this, and then you apply the special rule. Okay?
Special rules.
I haven't told you yet. All right. Occasionally, what I get is I'll get kids that will look at this, and they will say, oh, I just square the x and I square the 3, and I get that. It doesn't ever equal this. It doesn't ever equal. In fact, this is so common, math teachers have given this a name. It's called the freshman, because algebra was taught freshman year. It's called the freshman's dream. By the way, this actually turns into this, right? Not that. This is called the freshman's dream when you turn that into that, because it would be sweet if it was just x squared plus 9. It's not. It's something else. So don't do this.
And so, class of 2010, I bestow upon you advice that has been prevalent in my life, in my household, and that would be, don't screw it up.
Yeah, don't screw this up, right? All right. So, same drill as yesterday. I'm going to give you an example. Each row, you're going to do the math. You're going to use either the distributive property, or you're going to stack. You're going to tell me what the answer is. Okay? So, row 1, right? Table 1. This is your problem. You're going to write x plus 3 times x plus 3. You're going to tell me the answer. Row 2, x plus 4 times x plus 4. Row 3, 2x plus 3 times 2x plus 3. Last row, 3x plus 4 times 3x plus 4, and I'll do this one. All right, you got 20 seconds. Go. Row 1, you're doing x plus 3 times x plus 3. Sarah, you doing this? Okay, make sure you're paying attention. You're doing the work.
Anna's got the answer.
Well, we'll just hold. See, have someone else do it and confirm. Row 2, you're doing x plus 4 times x plus 4. Row 3, 2x plus 3 times 2x plus 3, row 4. 3x plus 4 times 3x plus 4, and I got this one.
Wait, I'm confused on how you get the middle term.
You got to use the distributive property or stack them. Remember binomial times a binomial. Last week's stuff.
But I thought you said it's a special rule from last week.
Remember I said that this turns into x plus 4 times x plus 4.
Oh,
And
it's
then
not
you
minus.
just
Yeah.
You gave us one, but that's cheating.
all right, first row, what do you got for an answer? Okay. 3 times 3 is 9. Remember, when you write x plus 3, I like stacking. X plus 3, 3 times 3 is 9. 3 times x is 3x. Bring down to 0. X times 3 is 3x. X times x is x squared. When you add, you get 9, 6x, and x squared. What's the problem, Julie?
Oh, okay, now I.
What's 3 times 3, Julie? So what's your question why we got 9?
Because, like, they're saying it was like yesterday, but X was
It's not like yesterday.
But you said
You just.
Yesterday was a special case where it was x plus 3, x minus 3. Now we're doing x plus 3, we're doing the square of a sum. It's a different problem. Okay. Row 2, what do we got? Answered. I got x squared plus 8x plus 16. 4x plus 4x is 8x. All right, I'm thinking I'm losing some attention here. Is anyone lost on how I'm getting these answers?
no.
Julie, how many of these do I have? So I write 2 of them, x plus 4 times x plus 4, and I just do the math. 4 times 4 is, that's where that 16 came from. 4 times x, bring down to 0. X times 4. When you add, that's where the 8x came from. And x times x is x squared. That's where that all came from. This is what your quiz was on that you took last week, by the way.
Oh,
All right. What do we got, third row?
4x squared plus 12x plus 9.
Last row?
Wait, what did I do wrong?
And the last one, we get 16x squared plus 40x plus 25.
so
Okay.
for the.
We're not there yet. We're not there. Okay, now everyone stop what you're doing. We're going to repeat what we did yesterday. So we got 5 examples here of what happens when you have the square of a sum. Now the question is, how can you look at this, or I should say, how can you look at this shortcut method? How do you get to that? This one's hard. Really, you could probably figure out how we get the 9, the 16, the 9, the 16, and 25. How do we get the last number?
By times last.
By taking this number and,
Multiplying it.
Right.
Right. So
in other words, squaring it. So we get this number by taking this and squaring it. Stay with me.
That's what we did yesterday.
That is what we did yesterday. So it looks like part of this is sort of kind of like yesterday. You get the last number by squaring the last number. How do you get the first number?
just
Okay, that's exactly like what it was yesterday. You get the first thing by squaring this. So you take A and you square it. Okay, I really don't have everyone's attention. For this special case one, you get the first term by squaring the first term. You get the last term by squaring the last term. Now comes the $25 question. How do we get the middle terms? Where do they come from?
Could you square the first one and then add them together?
We square the first one, we square the last one, we add them together, we don't get the
If you
second.
just square the first or the last one and add
If we square 3, we get 9, and add it to 2, we get 11, not 12. What do you got?
maybe if you did 2x times 3 and then
So she's saying something, if we did 2 times 3, we would get,
6.
and then we don't square it, is that right? 3 times 4 would be, and double 12 would be, ooh, it works for this one, it's a pattern. 4 times 5, double 20. That's what's going on. So let's wrap this up. In box 1, we're going to write the rule. This is only for if it looks like this. Only if it looks like this. This is called the square of a sum. To get to the answer, you take A and you square it. To get to the last thing, you take B and you square it. And oh, by the way, add. There's no minus signs. To get to the middle term, the hardest one, we took A and B and we did what? And then doubled it. So in other words, 2AB. That's what you will do today. Half of it, because we still have the other half. So this is what you write in box 1. To turn that into this, take A and square it. Take B and square it. This is definitely not what we did yesterday. Yesterday we just squared A and B and we put a minus sign in between and we were done. Today you got some work to do. Oh, by the way, I would like you to do these in order though. Don't do A, then B, then the middle. Do the first, do the middle, do the last. You take A, you square it. You multiply A times B, you double it. You take B and you square it. We put pluses. Everything's a plus. Yesterday everything was a minus.
The opposite.
Yes.
Because it's just divided.
It's the same thing except with minus signs. Okay, so here we go. Rule says you take A and you square it, right? So what's this squared?
X squared.
So you write x squared. What am I doing here? Oh, I'm showing you, oh, by the way, it works. All right. Now using the shortcut rule, we take A and square it, we get x squared. We take this times this and we get
3x.
double it.
6x.
We take that, we square it, we get that. That's the rule. You take the first one, you square it. You take the last one, you square it. You take A times B and double it. That's the rule. Algebra is really about noticing patterns, figuring out a rule, and applying the rule. The issue in algebra is remembering all the rules. We're up to our second rule.
Wait, so how do you get them?
You take the last thing, you square it. Take B and square it. Take 3 and square it.
Oh, okay.
Right?
Oh, so that's
Take the first thing, square it. X times 3 is 3x, double it. Take 3, square it, you get 9.
I think we only need to see that one thing. So from instantly.
Yes. But it only applies if it looks like this. Most of them will not. We will spend one class on this. We will spend 3 or 4 classes on the ones where it doesn't look like this. Now, here we go. Take the first thing and square it. What do you get?
X squared.
Okay. What's x times 9?
9x.
Double it.
81.
Double it.
No.
18.
X. Take the last thing and square it.
81.
And you're done. Sarah, you with me? Hey, I don't see you watching the board. Okay. Let's do another one. When it's the square of a sum, this is what you do. Take the first thing and square it.
6x squared.
How about 9x squared?
Oh, yeah.
What's this times this?
14.
X. Double it. Take the last thing and square it.
10. Oh, yeah.
You tell me. Okay, it took a while to get to this, but once you see it done, now it's kind of, I don't know if it's easy, but it's certainly not hard. We'll do the hard ones next week. These are the easy ones. Chris, walk me through it. This is box 2.
2 times 2 is 4.
X times X is,
What?
X times X is.
No. Oh, excuse me?
You got to take that whole thing and square it. I'm okay with 2 times 2.
2 times.
But it's the whole thing squared.
You only do 4x.
4x. X times X is,
Squared.
okay, so 4x squared.
Okay.
The middle one we get by multiplying this times this. What's this times this?
14. Wow.
14x.
14x.
Double it. Because remember, we got to double it. That's what the 2 means. 14x doubled would be?
No.
How about 28x? And then the last thing?
7x.
So multiplication table in front of your face at all times. So the first one's 4x, the last one's 49, then the middle term's 28x. Julie.
Wait.
Oh, then x squared times x squared is x to the
Why
4.
would
We add the exponents.
Why would?
Yeah. Yeah.
Why would 28 be our
Say again?
Why would 28 be our
Because remember, the middle term is you take 8, multiply times b, and double it. Okay? So, together, or you want to do it by yourself? Okay, first one together. Okay. First one squared. X times x is?
X squared.
X times 1 is? Double it. 2x. Don't forget your x. Last one squared gives me a, be careful, gives you a 1. Sarah, I don't see your pencil moving. Let's go. Come on. We got to do these. Okay. Do these.
Freeze.
All right, the middle one. The first number squared is 4x squared. First times the second is 10x. Double it. So if you're going to forget something, you forget to double it. You'll remember it's a times b, but you forget to double it. And then 5 squared is? Not 10, 25. Kaylee, yay? Okay. Typically what I'll get is I'll get people to say, yep, I see what's going on. And then they'll assume that, yeah, I can't make a mistake. This is easy. And then you got to do, it's like, an athletic thing. You got to practice it. You got to do 20 of these type thing. I didn't give you 20 of these for homework because remember, we got another flavor right after this. So I'll give you about 10 of these to practice on. All right. It isn't. It's really easy after we do this one. First one squared is?
14. No.
16, sorry.
16x squared. First times the second is? 8.
16x.
16x, he's already doing this without me even telling. And the last one squared is?
Plus 4.
Yes?
Smart guy.
Okay, algebra is a, Kaylee? Because remember, we do a times b, so what's this times this? And then double it. So 4x times 2 is 8x, double it will be 16x. Okay, second flavor. Guess what the only difference is?
Dividing.
What's the only difference?
Yeah,
All right. No, that's the next thing. The difference is it's the square of a difference.
What does that
Okay?
mean?
So if we were to, and we won't do this, if we were to do this, right? For instance, this one, if I did 2x minus 3 times 2x minus 3, you get a negative times a negative. Your last term will always be
Positive.
your first term will always be, but your middle term will be, and it's going to be the same thing. This times this,
6x.
and double it.
Breathe.
So this is the one that if you mess up, it's because you'll mess up the signs. Write this down, box 4. This is the rule. It looks exactly like the previous rule, except the middle term will always be, negative. You would think that everything would be negative. It's not. The one that's positive, everything's positive. The one that's negative, the only thing that turns negative is the middle term. The reason being is because the last term, you get a negative times a negative, it turns into a positive. The middle terms, you get a negative 6x and a negative 6x. When you add those together, you get negative 12x. This one. Okay. So even though it was two flavors today, they're both basically the same, except there's a sign difference between the two. Okay. Well, you're not going to like next week.
Okay. This started in my head since like we started that weird thing with like the whole.
Yeah. It's algebra is hard. It's not an easy course.
Algebra is so easy. I didn't catch it.
Okay.
Oh man, I think I did it.
All right.
I think I did
Let's see an example. Notice this is the rule for the square of a difference. Square of a difference. So if you don't notice it's the difference, meaning subtraction, and you do the other rule, you're going to be off by a sign. You'll have the right numbers. Your signs will be wrong. First thing squared gives me.
9x squared.
First times the second gives me
15x.
technically negative 15x, and double it.
30x squared.
Technically negative 30x, and the last one squared gives me positive 25. Make sure you're asking a question if you don't get this. Not to put the fear factor, but like no joke, we can all pass this, right? If you don't pass Algebra 1, you're signing yourself. There is no special dispensation. Well, yeah, but I'm a nice kid. I shouldn't have to go to summer school. It doesn't work that way. Well, I tried some of the time. It doesn't work that way. You fail Algebra 1, you don't graduate high school. You have to make that credit up. So in our school, if you fail arts, you have to make that credit up. You don't graduate. You fail PE. We have a 28 credit graduation requirement. That's every class. We say this, and it makes sense. Why would I teach you a course that's not important? We're going to make you take a course we consider important. Therefore, we make a graduation requirement of all your classes. You go to Falcon High School, you can fail quite a few classes, not math. That's one we got to pass. Their core classes are the same as us. You know, they get past core classes. But if you fail one of your electives and it's underwater basket weaving, right, or something like that, you can fail it and still be okay. Our school isn't like that. Okay? All right. This is box number 5. Here we go. It's the square of a difference. Square of a difference. Square of a difference. First one squared gives me 16x squared. A times b gives me
24x.
A times b gives me
12x.
negative 12x. Double it.
Is 24x.
All right, there's too much chit chat going on. Please stop. A times b is negative 12x, and double will give me negative 24x. And the last one squared gives me.
Oh my gosh, I did it.
You did it right. Okay.
16x.
Take the first thing squared. Whole thing.
Oh, I did it right too.
Okay. Practice. Here we go. Box 6. Box 6. Riley says I've already finished this. Anna says she's already finished it. Harley, I can't tell. You finished it? Can I just call you Harley again? I had to think about that for a second. I got her sister too, and I gotta make sure. All right. First one squared is a times b would give you minus 1x. Double it would give you minus 2x. And then negative 1 squared is positive 1. Okay? By the way, what typically happens is you get really good at this rule, and you forget all about the rule we did yesterday. The rule of yesterday was x plus 3 times x minus 3. Different rules. 2x would give you 4x squared. A times b would be negative 10x. Double it, negative 20x. 5 squared, 25. Last one, that gives me x squared.
Excuse me?
Yes, ma'am.
Can I have Lily Dagerpod for dismissal, please?
She's on her way.
Thank you.
Lily, we did not do factoring. Factoring would be the reverse. I'm going to give you this. You got to turn it into this. Here's how it's done. The square root of 4x squared is 2x. The square root of 25 is 5. You have to notice that I got a minus here and a plus, so the pattern would be with a minus. The ones with addition, all 3 of these will be plus. You'll just make it a plus. There's your factoring. All right, there's the last one. First one squared is x squared. X times negative 2 is negative 2x. Double would be negative 4x. And then 2 obviously squared is 4. We good? And you just heard me teach the factoring class to Lily. I was a bit too quick, so we'll do it a little bit slower. All right. So I gave you this. Watch the board, please. You turn it into this. That's called simplifying. We're going to do it in the opposite order now. I'm going to give you yellow. You're going to turn it into this. That's called factoring. Okay? So the cool thing is that you don't have to write this down. The cool thing is here's our two formulas. If I write them in opposite order, instead of going from here to here, right? I'm going to go from here to here. The nice thing is, look, this says A, this says A. This says B, that says B. We got to take the square roots. The square root of B squared is B. The square root of A squared is A. The only thing you got to pay attention to is the fact that two of them say plus plus, one of them says minus plus. The one that says minus plus winds up with a minus sign. The one that says plus plus winds up with a plus sign. And then also remember this. This is only for special cases. This does not apply to the ones that aren't special case. We get a whole big long list. Some of you will be struggling with this next week. But for this lesson, it's not too bad. Hey, which model is this, the top or the bottom? Is this the top or the bottom? Look at it. Does it match the top or the bottom? So therefore, our answer is going to have a minus sign in it. You see where I'm getting that from, Carly?
Oh.
And do you see that this one has nothing but pluses? And that this one has a minus sign and a minus sign. So is the example here the top or the bottom? The top has plus plus. It's the bottom. So we know our answer is going to look like this. So here's how it's done. You ready? Take the square root of the first. 2x. Hey, pay attention. We take the square root of the last. We put a minus sign in between. Right? You do need to ask yourself this. Is the first and the last a perfect square?
Wait,
and
what?
first, let me just explain it. You do have to ask yourself, is the first a perfect square? 4 is a perfect square. And the last a perfect square? 25 is a perfect square. Here's the kicker. The ones that I'll give you tonight for homework, they're all like this. The second question, we can answer it, but it will always be yes for tonight's homework. A week from now, the special case will be mixed with the normal ones. You might not even realize it's a special case one. But you have a middle term. The middle term has to be the square root of this times the square root of this double. Is it double AB? A is 2, B is 5, 2 times 10 is 20. It is double. I said that wrong. 2 times 5 is 10, and 10 times 2 is 20. There, I said it correctly. Okay. Hey, top one or bottom one?
Top.
So we know our answer is going to be a plus b squared. Stay with me.
X.
Okay. Square root of x squared is?
36.
Square root of 36 is? So it's going to turn into x plus 6 squared.
What if it's minus?
And it turns into that.
But on the homework there's 24. There's not a
Does it look like the top or the bottom?
the bottom.
Then it's that answer.
No, I mean the last term. You know how you're supposed to take the
Yeah, square root.
term, the square root.
What is it?
Negative 24. There's not a square root of negative 24.
It shouldn't be negative 24. It should be positive 24. Let me look at it. Yeah, I think you copied it down wrong.
No, I kept looking at it.
But these are just written out of order. Here's your first, here's your middle, here's your last.
So you have to change the order.
Yeah. So apparently on one of the ones, they wrote the trinomial out of order.
Oh, I don't
Yeah.
want to do that.
Did I do it on that one?
Well, yes. All right. Here's another one. Hey, is this a perfect square of 64? Hey, is 81 a perfect square? Square root of 64 is? Square root of 81 is? 8 times 9 is? This one is not double AB. That one is not a perfect square. So I wrote this as just an example. There's none of them like this tonight for homework. Next week there will be. So before you assume that everything's a perfect square, you do have to ask yourself that last question. So let's look at one that is. Hey, is this top or bottom? So it's going to look like this. Square root of x squared is. Square root of 9 is. So it's going to turn into x squared. Hey, 1 times 3 is 3, double 3 is 6. That's the second part. Is the middle term double AB? Sarah and Julie, seriously, all right? You gotta trust me when I say, if you pay attention and you work, you will get this. If you can't pay attention for 50 minutes, Algebra 1 is tough. You're wondering why you don't have A's in the class. You gotta ask yourself, did I really pay attention? You could also ask yourself this, and this applies to some of you. Did I pay attention until I'm like, okay, I got this. I'm not sure why he's still talking. That always applies. If you're the kid that's sitting there like, yeah, I got this after the second example. I'm not sure why he's got 5 examples. I have 5 examples because I have lots of kids I got to teach. Some kids get it the first example. Some kids at the second. Most kids, it takes quite a few examples. If you can honestly tell yourself that, yeah, I've been paying attention, I got all this, I just ask you don't do things that interrupt other people's learning, right? You don't ever hear me mess around too much with Riley, Brandy, or Anna, because when they get it, they just put their heads down, they do their homework, right? But please don't have me calling you like, hey, you guys need to pay attention. This turns into bad stuff. All right, square root of this number is?
11.
Square root of that is?
X.
So it's going to be first or second minus.
X squared.
Not x squared, just x. Oh, quantity squared, yes, 100%. I see what you meant. This is a tough one to read. We wouldn't say 11 minus x squared. We would say the quantity 11 minus x squared. And that tells you there's parentheses. Not that I'm going to say if Tristan's got it, you all should get it, but I'm just going to say. No, I didn't say that. You said that. No, I wasn't even thinking that. I was thinking more of the speech I just gave you, that if you pay attention, you can all get this. Generally, what happens is I get a kid that just doesn't pay attention, and this is weird stuff. I'm not going to show this to anyone a year, like the 8th graders. They're not going to know what the heck they're doing. She would cry, right? What's the answer, Sierra? This is Josie's question. You see it? You see this? What's wrong with this? It doesn't look like this.
So there's no square root.
So when it looks like this, you got to make it look, I'm saying when it looks like this, you got to make it look like this. I need to move this 9 over here. So I'm just going to rewrite it so it now looks correct.
It's 2x and 3.
Quantity squared, and now I know Sierra knows what she's doing.
Oh, okay. So
Right?
if it's not right, just.
So Josie, how many of these were on the homework?
About like 8.
No, not like that.
Not like
Josie.
that one. Oh, but like factoring.
Where is mixed up?
This one.
There's only one that's mixed up, and you should catch it. Okay? In fact, that literally might be the one.
No.
It was a 9, though, wasn't it?
Yeah.
Okay. Okay. Last one. Notice you got squares on both ends. Okay. This was was this Sophia's question? Somebody asked it over there. They asked it, what happens if the last one's squared? Hey, first one square root is? Last one square root is? Which one is it? Top or bottom? So it's got a plus.
And then, yeah. And then the next one is 2x.
Yes? All right, last one.
2x.
What do you got, Kristen?
2x plus 9
It
quantity
was
squared.
114 all. Page 210.
I threw a tricky one in here at the end, and I just want you to make sure, because if we get to next week, it turns out that if this was, that form factor would be true, but 2 times 9 is 18. Double 18 is 36, not 18. So even though I threw this in there, none like this for homework, I just want to make sure it's got to meet both requirements. Yeah, the A in the first term and the last term they do meet the requirements, but the middle one was not double AB. It was only it was just A times B. Next week, this will be an issue. We'll look at one, and someone will say, hey, look, it's one of those perfect square ones. And we'll find out it's not. We got to use the rough method of factoring the subject. Okay. This one right here, to factor this one, if it is even factorable. Not all trinomials are factorable. This one would take us about 8 minutes to factor. So next week, I'm going to show you it. Kids that are fast at it can do it in about 5 minutes. Okay. This one's not factorable because this isn't double AB. It's only just AB. If it was, though, you're right. It would be 2x plus 9. Okay. Questions on anything we did? Hey, seriously, we are in the heart of the hard, challenging material. If you pay attention during class, you will get this every day. If I only get half of your attention, you're signing up yourself up for summer school. Right? Right? Yes. All right, stay in your seats. I didn't think I assigned those, or unfactorable ones. Anna says that 27 and 28 are not factorable. No, they're factorable. Yeah. Turns out that 29 and 32 are unfactorable. I didn't see
I don't know if I heard my name. Oh, that's fine. Or like whenever you do those like stabs in your
This one was like this one.
built like
Here. Notice totally in order first, and then back. Yeah. Or you just do the whole thing in your head. You know what? I mean, some people would tell me the answer just by looking at that. I don't have to. Hey, the instruction I gave you was stay in your seat. Sierra, find your seat. Rylan, Chris. Just chill in the bell rooms. All right, e-learner. No, Haley said her internet was down, so she's not on. Haley, if you run into any issues, send me an email or chat me up. Either or. Have a good weekend.